Hello and welcome to this special Nomira class. Today we are going to be looking at IUPAC Nomenclature. This is a system of naming compounds in chemistry. Okay? It stands for International Union of Pure and Applied Chemistry. We adopt this system in writing exams and also in making references when you are in the professional setting. Okay? So we are going to be looking at examples. When you have a compound like this or like this, you can commonly call this hydrochloric acid or hydrogen chloride. Okay, and it is very simple like this because it seems that there is no pattern of naming this compound. But then for this particular compound, one may decide to call this carbon dioxide, the other will decide to call it carbon 4 oxide. Which of these two follows IUPAC system of naming compound? The person that says this is carbon dioxide named it the way they trivially call it, or they use the common name for this compound. Then the other person that says that this is carbon 4 oxide followed the IUPAC system of naming compounds. In this class, we are going to be looking at how we adopt IUPAC in naming chemical compounds. Let us see how to name this particular compound. This is a binomial compound, meaning that it contains only 2 elements. When a compound contains only 2 elements, the first element becomes the unknown, in which case this is going to be C as our unknown. Then we will be adding the oxidation numbers. This oxygen comes with 2, so you will use it to multiply the oxidation number of oxygen. The oxidation number of oxygen is -2, then equal to 0. We are going to be using equal to 0 because this is a neutral compound. If in case the particular example that is given for you to solve and get the name comes with a charge here, whether plus or minus, whether it is 1 or 2, you will have to use that particular ionic state here and place it here. If you have just minus, it will become -1 here. If you have -2, it becomes -2 here. Okay, so the example we are just solving here is a neutral compound. It means that it is equal to 0. So I will still have to teach you how to get the oxidation number of oxygen. But then let me finish with this. We have C, plus times minus is what? Minus 2 times 2 is what? 4, equal to what? 0. Then we have C equal to, when this crosses over to the other side of the equality, you have what? Plus 4. It means that the oxidation number of carbon in this compound CO2 is +4. Therefore, the name is carbon 4 oxide. This is the 4 here, represented in Roman numeral. So this is the IUPAC name for this compound. How do we get the oxidation number of oxygen as -2? The oxygen is atomic number 8, right? So using the old method of electronic configuration, you have 2 and 6. We are going to be working with the valence electron because valency is about the combining power of an element, and then it tells more about the oxidation number because the oxidation number is determined by the valence electron. Okay, so we are going to be working with the valence electron. Therefore, place your proton here and your electron here. At the point where this atom is neutral, is electrically neutral, place the valence electron to be here because the number of protons has to be equal to the number of what? Electrons, so that the atom will be what? Electrically neutral. Then at this stage you have done justice to it. The next stage is to what? Bring down this 6 because protons do not participate in chemical reaction. Therefore, here remains unchanged. But for this electron will have to change. But for you to understand why electron changes, you know that in reaction, chemical reaction, it is the electrons that participate in chemical reaction. It is the electron that either donates or what receives extra electrons. So how do we judge this? Bring out a chart and then do it this way. If the number of electrons are less than 4, they are all lost to what? Give 0. So you lose all the electrons to become what? 0. Then if the number of valence electrons are what? More than 4, they gain more to become what? 8. In this case, for oxygen, the valence electrons are more than 4. They are 6 in number, so they are more than 4. So they will gain to become what? 8. Therefore, when you bring out your oxygen to find the ionic state and therefore the oxidation number, you ask yourself, electron and proton, which one is bigger? Definitely 8 is bigger than 6. So electron is bigger than what? Proton. You ask yourself, what charge does electron contain? The electron contains a negative charge. Then the next question you ask yourself is, how many numbers is electron bigger than the proton? The electron is bigger than the proton by what? 2 numbers. So you have what? -2. The oxidation number is what? -2. This is what we use here. This -2 is what we use here in solving and determining the chemical name of a compound using IUPAC system. Alright, I'll give further examples for you to understand this. What if we choose to solve for CO? CO could be trivially called carbon monoxide in biology, but in chemistry we will adopt what? IUPAC system. We can call this thing carbon 2 oxide. How do we get that 2? Carbon is the first element in this binomial compound, so it will become the unknown plus there is 1 of oxygen here. We will multiply it with the oxidation number of oxygen. We have determined the oxidation number of oxygen to be what? -2. So we have -2, then equal to what? 0. So we have C. Plus times minus is minus. 1 times 2 is what? 2, equal to what? 0. So C is equal to, when this crosses over to the other side, the minus will change to what? Plus. So we have what? +2. In other words, the oxidation number of carbon in CO is what? +2. Then we name this compound as what? Carbon 2 oxide. This is the IUPAC name for this compound CO. Alright, so we are going to see further examples. Let us determine the IUPAC name for calcium carbonate. Calcium carbonate is a correct name for this, but it is the common name, not the IUPAC name. How do we find the IUPAC name? First thing is to know the oxidation number of calcium, right? So calcium is atomic number what? 20. Using the old method of electronic configuration, we have what? 2, 8, 8, and then 2. 2 plus 8 is 10, plus 8, 18, plus 2, 20, right? So we are working with the valence electrons. So bring out your proton and what? Electron, right? So the valence electrons are what? 2 in number. At this point, 2 is equal to 2 because at this point, the atom is electrically neutral. Knowing that P, that is your protons, they do not participate in chemical reactions, so it remains unchanged. Then you ask yourself, is this 2 bigger than 4 or less than 4? 2 is less than 4, therefore it will lose to become what? 0, right? So you bring out your calcium, then you ask yourself, is proton bigger than electron? Yes, proton is bigger than electron, so the sign that proton contains is what? Plus. How many numbers is proton bigger than electron? Proton is bigger than electron with just 2 numbers, so you write 2. In other words, the oxidation number of calcium is what? +2. This is what we are going to use in this calculation, right? So we have what? +2 plus carbon is in the middle. Now, when you have 3 elements making up a compound, the one in the middle becomes the unknown. This is different from what I said before for binomial compounds where there are only 2 elements. In the case where there are only 2 elements, the first element becomes your unknown. But when you have 3 elements, the one in the middle becomes your what? Unknown. When you have 4 elements, the third one becomes your unknown. All right? So we are going to make C the unknown plus, then oxygen is carrying 3. We use it to multiply the oxidation number of oxygen, which is what? -2. When you use this same pattern, you will realize that oxygen is -2. The oxidation number of oxygen is -2. We have done it before, right? So this is equal to what? 0. We have 2 plus C. Plus times minus is minus. 3 times 2 is 6, equal to what? 0. We have C equal to, when -6 crosses over to this other side, it becomes +6. When +2 crosses over to the other side of equality, it becomes -2. So carbon is equal to what? +4 here. The oxidation number of carbon here is +4. That will give this name as what? Calcium tri. 3 means tri. Calcium trioxocarbonate 4. This is the IUPAC name for calcium carbonate. We call it calcium trioxocarbonate 4. This is how you name it. Calcium, then you start here. Trioxocarbonate 4. The 4 you got here. Calcium trioxocarbonate 4. Calcium trioxocarbonate 4. Now let me give you another example. Let's see a compound like H2SO4. In this case, hydrogen comes with 2, and the oxidation number of hydrogen is +1. How do you determine that? Pay attention. Hydrogen is atomic number 1. Electronic configuration is just 1. It therefore means that it will lose the 1 electron. But let's just follow the same principle I've just laid here. We have 1, 1 when the atom is electrically neutral. Then this doesn't change. Then this will lose the 1 because it is less than 4 to become what? 0. So hydrogen here, proton is bigger than what? Electron. So the charge that proton contains is plus. How much is 1 bigger than 0? It's just 1. In other words, the oxidation number of hydrogen is +1. This is the +1 we have written here. Plus the middle number, the middle letter is S. So it will become our unknown. Then plus oxygen comes with 4. You use it to multiply the oxidation number of oxygen, which is -2, then equal to 0. So we have what? This times 1 is what? 2 plus X. Plus times minus is minus. 4 times 2 is 8, equal to what? 0. S equal to what? When this crosses over, it becomes 8. When this crosses over, it becomes -2. So S is equal to what? +6. Therefore, the name is hydrogen 4 means tetra. Hydrogen tetra oxosulfate. Sulfate what? 6. Hydrogen tetraoxosulfate 6. If you want to call this as an acid, knowing that hydrogen represents or indicates that this is an acid. So you have to start from here, which is tetraoxosulfate 6 acid. Tetraoxosulfate 6 acid. But if you want to call it this other way, by mentioning hydrogen, you will call it as hydrogen tetraoxosulfate what 6 without putting acid. So we will solve few more questions. I believe we have done justice to this. We will solve few more questions so that you will understand this topic better. So what if you have two elements making up a compound, that is a binomial compound, in this format? How do you name this compound? Nitrogen is the first element here. It becomes your unknown, right? But nitrogen comes with 2. In other words, we have 2n plus, then oxygen comes with 4, bracket what? Minus what? 2, which is the oxidation number of oxygen, then equal to what? 0. So we have what? 2n plus 4 times minus 2 is what? Minus 8 equal to what? 0. So we have 2n equal to what? When this crosses over, it becomes plus 8. Then you make n the subject formula. So we have n by dividing both sides by what? 2. We have n equal to what? This divide is 1. This divide is what? 4. So the name of this compound will become what? Nitrogen. We have 4 nitrogen, 4 oxide. Thank you for watching this wonderful video. Please kindly subscribe to our YouTube channel, Nomira Virtuals.